Hello students, in this session let us solve one more question of simply supported beam. In this question it is given that a simply supported beam of length 6 meter carries a point load of 3 kN and 6 kN at a distance of 2 meter and 4 meter from the left hand. Draw the shear force and bending moment diagram for the beam. So this is a question of simply supported beam where we are given with 3 kN and 6 kN loads at a distance of 2 meter and 2 meter. Total length of the beam is 6 meter and we have to draw the shear force and bending moment diagram for this beam. Let us solve this problem. This is a simply supported beam and we are given with two loads are there, 3 kN, this is point load, 6 kN point load at a distance of 2 meter and 4 meter from edge A, right? And we have to draw the shear force and bending moment diagram for this simply supported beam, right? So between A to C there is no load. We can take one section between A to C, one section between C to D and one section between D to B. Before that we want to find out the reaction. What is the reaction at point A? You know that for simply supported beam we always want to find out the reaction, otherwise we won't be able to take the forces on both the sides, right? So what is reaction at A and what is reaction at B? RA and RB, this we have to find out first. For finding the RA, take the moment of all the forces at point A, about point A. So take sigma MA, moment of all the forces about A, and that should be equal to 0 because the body is in static equilibrium. So at A point the sum of all the moments about A should be equal to 0, right? So let us take the moment. How many forces are there? How many forces are there? There are basically 4 forces: RA, the reaction, RB, reaction, 3 and 6, right? So 1, 2, 3, 4. So the moment of RA about A is 0 because the perpendicular distance is 0. Moment of 3 about RA, this is 2 meter, 3 multiplied by 2. So this is 3 and take it clockwise, clockwise as positive. So 3 multiplied by 2, 6 multiplied by 4 plus 6 multiplied by 4 because it is also clockwise, and RB is anti-clockwise. So RB multiplied by 6 minus RB multiplied by 6, that should be equal to 0. So from here you will get the value of RB. Find out the value of RB. This is 6, this is 24, 6 plus 24, this is 30, 30 by 6, this is 5, so 5 kilonewton, 5 kilonewton. So RB is 5 kilonewton, right? Similarly we can find out RA. You can take the moment about this point, or you can take that sum of vertical forces, sum of total vertical forces should be equal to 0. You can take this also, right? So you can take that sigma F in vertical direction should be equal to 0. So this will give out that RA plus RB, these are upward force, and 3 and 6 are downward forces. 3 plus 6 should be equal, right? So RA plus RB should be equal to 3 plus 6, 9. And if it is 9, this is 5, then RA should be 4. So RA should come out to be 4 kilonewton. So we have got RA equal to 4 kilonewton and RB as 5 kilonewton. So we have received these two forces, right? Now we want to draw the shear force. Take the section. Let us take the section at this point. From this we are taking from A at a distance x from the A, and capital X is the section. So what is the shear force here? Find the value of shear force. Fx, that will be equal to sum of all the forces to the left or to the right of the section. We are taking to the left of this section. To the left of x there is only one force, that is RA, that is 4 kilonewton, right? So Fx will be equal to RA, and upward force, leftward upward force is positive according to sign convention. So this should be equal to RA, which is equal to 4 kilonewton in positive sense, right? And this value will be valid between A to C when there is no force. So A to C it is valid. Then what is FA? Because it is constant, so FA will remain same. Fa at x is equal to 0 is 4 kilonewton, and Fc at 2 meter, Fc at 2 meter should again be 4 kilonewton, because the force is not varying, it is constant. So let us draw now. This is 4 kilonewton like this, right? 4 kilonewton, and it will remain same like this. So this is 4 kilonewton, isn't it? 4 kilonewton, and it is straight line, uniform line, horizontal straight line, like this, right? 4 kilonewton from A to C, isn't it? So here we are drawing the shear force diagram. It will come here in the shear force diagram. Now let us take one more section here. We have to take between C to D, because the forces are changing here. The 3 kilonewton is added up, so you have to take one more section here between C to D, and let us take this section like this, right? From this point, right? And say this is x1, and this section is capital X1. Now what is fx1? Sum of all the forces to the left of the section, algebraic sum of the forces to the left of the section. There are two forces, Ra, and this 3 kilonewton. So this Ra is positive because it is upward, and 3 kilonewton is negative because it is downward. So we will write this is Ra minus 3. Two forces are there to the left of x1, so this will be equal to Ra is 4 minus 3, this is 1 kilonewton, and this will be valid between C to D. This is valid between C to D, right? So what are the forces then at C? Where x is equal to, x is equal to 2 meter. This is constant, 1 kilonewton. And what is force at D, where the x value is 4 meter, and the value is same, 1 kilonewton, no variation, right? So 1 to 1 with a straight line, with a horizontal straight line, right? So this was 4 and now it is 1, so there is reduction in force like this, right? And it is now constant, right? And this force is 1 kilonewton, this point, that is 1 kilonewton, and this point is 4 kilonewton, this point from here to here, right? And this is 1 kilonewton, right? And this is also 1 kilonewton, this is also 1 kilonewton. So now let take one more section from D to B. So let us take between D to B. You can take from right or left, whenever you feel comfortable you can take, but because we have already taken from left, so it is better to take from left only. So take a section x2 here from left, right? x2, and find out fx2 at a distance x2. This is x2, so fx2, that will be equal to, fx2 will be equal to sum of all the forces, Ra minus 3 minus 6. Three forces are there, Ra positive, minus 3 minus 6, though this will come out to be 9 minus 4, this will be 5 kilonewton, right? So this will come out to be minus 5 kilonewton, which is valid between D to B, minus 5 kilonewton, right? So and then what is the value of D, Fd, which is at a distance of 4 meter, that is equal to 5 kilonewton, isn't it? And again D to B, Fb is at x is equal to 6 meters, 6 meter, this will come out to be same value, no variation there, minus 5 kilonewton. So minus 5, so 1 to minus 5, go to minus 5 here, say here, and this minus 5 is consistent from D to B. So this is the diagram, right? This is minus 5 kilonewton and this is again the minus 5 kilonewton, right? And here it is positive and here it is negative. So this is the shear force diagram. This is shear force diagram for the given beam, right? Now we want to draw the bending moment diagram. How to draw the bending moment diagram, right? Bending moment diagram. So let us take a reference line here. Say this is the reference line, and this point is A, this is C, this is D, and this is B, right? And we want to draw the bending moment diagram. So what is bending moment? Sum of all the algebraic sum of all the moments to the left or right of the section. We are taking left section, x section, first take x, then x1, then x2. So mx, what is mx? That will be equal to mx. Moment of this RA about this, so RA multiplied by x. So RA, and whether it is positive, yes it is positive. So according to sign convention it is positive. RA multiplied by x. So this will be, and RA is 4, so 4x, and this is valid between A to C, right? Then what is at A point, MA? What is MA? Which is at a distance of x equal to 0. So this will be equal to 0. And what is MC? Which is at a distance of 2 meters, x equal to 2 meters, and that will be equal to 2 multiplied by 4, that is 8 kilonewton meter. 8 kilonewton meter, right? So this is 8 kilonewton meter. So from A to C, this is a linear variation from 0 to 8 kilonewton. So this is somewhere 8 kilonewton meters. Suppose this is 8 kilonewton, this point, and from 0 to 8, and a straight line, this line, right? So 0 to 8 kilometers. So this point is 8 kilonewton meter from A to C. We have drawn this, right? Now take another section, x1 from A, x1, right, at a distance x1. Now there are two forces. We have to take the moment of two forces, 4 kilonewton and 3 kilonewton. 4 kilonewton multiplied by this distance is x1. 3 kilonewton multiplied by this distance is x1 minus 2. x1 minus 2, because this distance cx1 is x1 minus 2. So cx1. So now take mx1. So this will be 4 multiplied by x1, 4x1, which is positive, minus because 3 is negative, 3 kilonewton multiplied by the distance cx1. cx1 distance is x1 minus 2. So x1 minus 2, right? And this is valid between C to D. This is valid between C to D. But what is the value at C? Bending moment at C, where the value of x is 2 meters. 2 meters. The value of x at C is value of m at C is 2 meters. Put here, you will get the same value, 8 kilonewton meter. And what is the value at D? At D, when D is 4 meters. So MD at x equal to 4 meters. Put here x is equal to 4 meter. You will get 16 minus 6, 10 meters, at 10 kilonewton meter. So from 8 kilonewton meter to 10 kilonewton meter, it is varying from C to D with a linear variation. This is a linear variation from 8 to 10. So you are getting here somewhere you will getting 10 kilonewton meter. From 8 to 10, a linear variation like this, right? And this bending moment is This bending moment is 10 kilonewton meter. 10 kilonewton meter, right? And then we can find out, we can take this section x2 at a distance x2 from A. So what will be mx2? Mx2, that will be equal to, now mx2 will be the moment of Ra, 3 kilonewton and 6 kilonewton, three forces are there. So moment of Ra, 4x2, this is positive, minus 3x2 minus 2 minus 6x2 minus 4, 6x2 minus 4, and it is valid between D to B, valid between D to B. But what is bending moment at D? At a distance of 4 meter. Put here 4 meter, 4 and then 4, it will become 0. So it will again come out to be 10 kilonewton meter. And the next value is MB at a distance of 6 meters. You will get the value of, put here 6 and then 6, right? You will get 0 value at B, right? So from 10 to 0 with a linear variation, this is a linear variation, 10 to 0. So 10 to 0, a linear variation like this, right? So this is the bending moment diagram. So this is a straight line, basically. So this is the bending moment diagram for simply supported beam, where the forces are given like this, right? This is positive and this is negative, this is positive, and this is bending moment diagram. So this is how we can draw the shear force diagram and bending moment diagram for this given simply supported beam.